All right. It says we're live, so I'm assuming we're live here. Day one at CAMX. I have two gentlemen joining me. Got Mark Adams with Polynt joining me he's on the far right side, and he is the R&D. Would you say R&D manager?
The specialty composites team.
Yes. Yep. And then also Wayne Huberty. He is the associate director of advanced composites at Mississippi State University. Right, he's got his, he's representing today. He's got his
business casual.
That's right, exactly. So glad to have both of you guys joining me on the show.
Great.
How's it been so far today?
Oh, it's been fantastic. Networking, being able to talk to people at the CAMX Awards.
Yeah.
Some really leading edge research going on there that's going to advance our whole industry. So it's been great.
Yeah. Fantastic.
It's fantastic to have people around.
Yeah.
Right. You've got so many like people that we partner with, and having them in a single spot, it's really nice. So I'll be talking to someone and be like, oh, sorry, I got to go talk to this person quick. I don't mean to be rude. And then while I'm talking to them, it's like, oh, there's someone over there. I got to go talk to them quick.
Right.
So
you're trying to wrap it up and,
yeah, that's right.
But it's hard to, in an event like this, because there's a lot to squeeze in 3 days.
That's right. It's too much. And like, if I look at the schedule, I think I'm busier here than I am at home.
Yeah, I totally agree with that. So let's talk about, before we get into talking about some of the technology, talk about your work. We'll start with you, Wayne, at University of Mississippi. Talk about your role there.
Yeah, so I'm the associate director at the Mississippi State Advanced Composites Institute. And so in there, we're focused on large out-of-autoclave processing.
Okay.
And so we were born and bred out of aerospace. So Boeing, when they closed the Huntington Beach facility, they opened up our facility, so we got some of their equipment there. And we were really the hands and feet of Boeing for a few years doing this out-of-autoclave large composite manufacturing.
Yeah.
When we had a dedicated director in 2021, he's like, hey, we got to branch out a little bit. He came in 2020, I came in 2021. And so now we're doing stuff, whether it's automotive, continuing with aerospace, we're doing infrastructure, we're doing a bunch of additive tooling, which you saw. So we're doing a bunch of additive manufacturing. So what we wanted to do is reach out and just do composites in general.
Yeah.
And having the capability, the biggest part we can make is 50 foot.
Right.
So we have a 50 by 20 oven. So big capabilities. We have a large RTM press. So we're trying to build those capabilities. And as you build it, people come in.
Yeah.
Because it's really unusual to have a public facing institute that can do those sorts of things.
Sure.
And we're also AS 9100 certified, so that means we have quality standards as well.
That's great.
So we're not the prototypical academic where we always say like they build it with duct tape and toothpicks, right? So we want to do real manufacturing and push that out to the industry.
Yeah, that's great. Now, how long have you been there?
So I have been there since January 1, 2021.
Okay.
That was a great day to move, COVID and January 1.
Great time.
But so before that, I was working specialty chemical. I'm a chemist by training.
Oh, okay. I guess you went to Mississippi State?
No, I didn't go to Mississippi State, nor did I plan to be in Mississippi. I always tell people I moved north, so I was actually working in Baton Rouge, Louisiana before this.
That's right. Okay.
And so went to LSU for graduate school, then worked for a specialty chemical company called Albemarle, where we were selling brominated flame retardants. And it worked out great because it's like Slumdog Millionaire, where we were looking at fracture toughness of stuff. And I had no idea what it was, so I had to learn what it was because I'm not a mechanical engineer.
Right.
And showed up at Mississippi State. And one of the things that we do is we stitch through the thickness of your fabrics. Right. So then you can control delamination in composites, and it increases your fracture toughness by like 10x. And so it was one of those like Slumdog Millionaires where like, hey, guess what? I know a little bit about that just because I was working on it, not because I'm smart.
Right. Exactly. It's sometimes timing's everything, right?
That's right.
Mark, tell us a little bit about your background. R&D manager at Polynt.
Right. So I'm the old guy here. I've been in this type of polymer space since the mid 80s, and started working up analytical chemist, then a formulation chemist, synthesis chemist, application synthesis, tech service, senior tech service, and then I moved into the management role where my last two companies, I've been involved in novel, new polymer chemistry.
Right.
So sometimes that involves looking at molecules. Sometimes it's taking existing molecules and make them do something they've never done before. And so that's kind of what we've been doing here with the 3D tooling,
Yeah.
is that the idea of using unsaturated polymers is not new.
Sure.
But taking it and being able to dispense it in such a way that you can creatively replace tooling, which if it's FRP tooling, it's going to take weeks and weeks to make. And if
Yeah.
it's metal tooling, it's going to take sometimes 18 months
Yeah.
to get a piece. So the idea is, and they hired me 6 years ago to come in. I work for automotive, come in, formulate these new products and work with vendors to be able to get the type of equipment that's needed. And that's one of the interesting things about what we're doing that the rest of the industry is not. Large format additive manufacturing has been around for a
Yeah.
while. It's been with thermoplastics. It's you can go to AirTech's booth. You can go and look at a number of places to see examples of that. But thermoset is a new approach to it, and it has some advantages and some disadvantages
Yeah.
over existing technology. But we have been partnering with MSU for some time now. They were able to buy one of the first largest LFAM thermoset printers.
Okay.
And so it was a good pair, good matching. And so we've been working together for maybe 2 years, maybe not quite 2 years.
Probably longer than that because
Okay.
time flies.
Yeah.
Yeah.
Time flies.
So anyway, that's what our group is doing. And so we're creating print media
Okay.
using polyesters or vinyl esters that can work at different temperature ranges of molding.
So, what are you looking at in terms of time frame for printing a typical prototype or a tool?
Yeah.
Depending on the size, of course, and
Right.
geometries and all that.
So we have printed a number of molds over the last 5 years. So
Yeah.
the program itself is still fairly new.
Okay.
And getting the printer technology, which required some custom German engineering, became available a couple of years ago. And so once that became available, we were able to take it to newer heights with that. But the lead times on fiberglass mold, which is where we kind of started out, so we were looking at more ambient molding.
Yeah.
And so we were doing things with thermal forming, we were doing things with open layup, that sort of process. But recently, working with Wayne and ACI, a lot of their work is with aerospace. So
Yeah.
we developed a high temperature media that now has a coefficient of thermal expansion is the term, but one of the reasons why aerospace companies like Invar steel is that it has a very low coefficient of thermal expansion. Well, our high temp media is right in that same range, which is
Okay.
very unusual for a plastic to be able to model.
Sure.
So instead of an Invar mold taking 18 months to get there, you can print, finish, coat if you need to in 3-4 weeks.
Wow. And you mentioned going back to aerospace, probably a big market is drone technology, right? So maybe you could talk a little
Yeah.
more.
So I think the big thing for us, as we're in aerospace, the sort of jump from 250F to 350F is a big jump in performance.
Yeah.
And that's exactly what Mark was talking about, trying to get these metallic tools to get there. And oftentimes it's Invar steel. Being able to do the processing at this elevated temperature with a really low CTE. And the other advantage too is as you do the chemical cross-linking, you can get that cross-linking through the Z layers.
Okay.
So one of the challenges right now is as you print, you're depositing your print, and then you have a melted layer on top of a melted layer.
Right.
And so that's typically the failure mechanism for these thermoplastics, right? And so in this case, what we do is we still print that same way, but then it'll react and actually can cross-link through the thickness.
Sure. Yeah.
So now our Z retention is much, much higher. So we have a talk at 2:30 where we'll talk about that. And what that allows us to do then is to do different applications. So not only are we doing open molding, right? So you can do open molding where you just do a hard tool, a vacuum bag, push resin in the system and cure it. So that's fine. One of the things we're looking at is doing the closed mold processing. And that's actually what we're up for an award for.
Yeah.
Where we're looking at getting to higher rate sort of R&D tooling. So we don't know exactly how many squishes one could get yet. But the goal is that imagine you have an R&D program, and I've heard this directly from customers where they say half of my budget for this DARPA program might be one tool That's going to take me 18 months to get.
Wow.
And so if we do it where, hey, I can make an R&D tool in a few weeks for a few $1,000s or whatever it is, what that allows me to do then is be able to make these programs succeed where they may have failed in the past.
Yeah.
And whether that's a drone shape, whether that's a top for a Corvette or whatever it is, right? It doesn't
Yeah.
really matter the shape
Yeah.
because at least for us, the shape is sort of inconsequential.
Mm-hmm.
You're marrying the capability to make the tooling really quickly.
Yeah.
It's dry fabric. You shoot resin in the system. With the Polynt material having either that sort of lower temp, room temp application or the high temp allows us to attack whatever mold or part we want to, right?
Yeah.
So it's a big enabler for us. I mean, we've seen it as well, and we felt the pain where I just needed to get some like flat aluminum cut, and it was going to be $20,000
Okay.
in 6 weeks, and I'm like, I just can't do those sorts of things,
Wow.
right? So, in the
Well,
the-
and if you look at some of the quotes that we got on Invar steel,
Yeah.
for even a small 3x6 mold, Jonathan, it was over $120,000. And so now you're comparing the cost of a tool of 120 grand down to somewhere less than 10, and you can get it in 3 or 4 weeks instead of months.
Sure.
There's quite an advantage.
Oh, wow.
And then, and Wayne alluded to this, but there's a couple of things that are really interesting about thermoset.
Mm-hmm.
With thermoplastic printing, you cannot turn the printer off. It has to be running the whole
Okay.
time.
Right.
And so you better hope that if it's a big print, you've got someone to work overnight. Thermoset, because it's chemically bonded, you can literally stop and start
and pick back up,
and
right?
pick
Go
back
to
up
lunch.
again.
Yeah.
And
Enjoy
you can
lunch.
stop and you can put a foam core in it and print right over it. That'll be in our paper this afternoon. You see
Yeah.
a video of that. So there's certain things, the Z-axis retention that you were talking about is because you're printing fibers in a liquid media instead of a solid media.
Sure.
So we have some micrographs we'll be showing where you'll see completely random orientation. So we have 80% product performance retention. And when you've got a compression mold and you're putting all that weight in the Z-axis,
Yeah.
you better hope that you have high fracture toughness and a lot of retention in mechanical properties. So we think that was a plus.
yeah.
Fantastic. And they can see over at CAMX Awards.
Yep.
They can go visit you guys. You'll be over there. I'm sure that
This afternoon.
you'll be kind of going back. I'm sure you'll be going back Polynt's.
3 times.
Three, yeah.
Times. And then also at the Polynt booth, we have the smaller version of what's in the
Yeah.
display. So you'll see a smaller tool
Okay.
and some smaller drones.
Yeah,
Okay.
and as a reference to your drone question, so we're making these 17-inch drones.
Mm-hmm.
We're able to cycle them in a minute and a half, and it's about $40. So
Wow.
super cheap, super fast
With carbon fiber.
with carbon fiber,
With
continuous
carbon fiber.
Yes.
Wow.
Yeah.
Very inexpensive.
Yeah.
Very fast.
That's very fast too. Yeah, exactly. Yeah. So, I mean, lastly, scaling, I mean, we talked about the opportunities in aerospace, drones, automotive. This opens up some pretty big opportunities once this technology rolls out.
Absolutely.
Some of these tooling guys may not like it, but
Well, they might love it too.
No,
'cause
of course.
They
They-
can get the tools when they need
right,
it, right?
right, exactly.
So,
Actually, there's a couple of companies here, contract tooling companies that we've dealt with.
Yeah.
And they're very interested in the technology
Sure.
because labor.
Well, that's
Labor
true.
is a
That's
huge issue and they cannot get skilled workers. So these big manufacturers, I won't mention any names, but they're global producers, can't find people to fill their tool shops anymore because no one's skilled to do that. So if you can break it down to an automated process, which is what we're talking about
Right.
here. And just this morning in the keynote address, we heard that the labor force is shrinking pretty dramatically
Yeah.
here in the U.S. Automation is the answer.
It is. No, that's a good point because it is hard to find those skilled people, people that want to show up and have the skill set needed. And I was taught we had a recruiter on earlier this morning who represents this industry, kind of specialty chemicals, advanced materials, and they said, by 2030 is like, that's a time frame where a lot of people are moving out of the industry, retiring, getting out, and there's just not enough people right now to replace a lot of the skills that we need. So, yeah, absolutely.
I don't know if
a good
I can
point.
put a plug in here, but maybe I can. One of the great things ACI does,
Mm-hmm.
Jonathan, is they are a funded school.
Yeah.
for training and teaching high school students, college students, the art of aerospace engineering.
Yeah.
And they come right up knowing maybe next to nothing. And you guys train them in how to do this. And I think that's something really special about what you do.
Yeah. That's great. Guys, thanks for coming by. Let me shake your hand and
Thanks, Jonathan.
hope it's a great show. Look forward to maybe catching up with you guys later this week. You'll be here through Thursday, both of you. Yeah. All right. Sounds good. Well, best of success at the show, and I'll stop by and say hello a little later.
Fantastic.
All right.
Thanks, Jonathan.
Thanks.